Hello everyone. So today we are going to discuss some properties of tree graphs. Let G be a tree, then the following are true. Okay. These four properties hold for any tree. The first property says that if the order of G is n, then the size will be n minus 1. And I have already proved this in a previous video. So today I am going to discuss these three properties. So the second property says that there exists a unique path between any two vertices. Why is this true? See, we know that a tree is a connected graph, right? And what is the definition of a connected graph? Between any two distinct vertices, there exists a path. So let me fix two arbitrary vertices Vi and Vj from the vertex set, and so there exists some path joining them. All right. Now, in order to show that this is the only unique path between these two vertices, I am going to take the help of contradiction. So I am assuming that there is another distinct path joining Vi and Vj, and another path exists. What does that mean? That means it is different from the first path. That means what? Either there is an entirely different or separate path. That means like this one, which shares no vertices and no edges with the first path, or second case, what may be possible, that there are some vertices in common and maybe some edges also in common, but they are not entirely same, right? So in either case, what I am seeing that there exists some edges which are not in first path but in second path, or I can say that in the second path but not in the first path, right? And in either case, what I am getting a cycle, isn't it so? Okay. So what I'm seeing, there exists a cycle in G, and this is a contradiction. Why? Because a tree is an acyclic graph, or a graph in which there exists no cycle, and so the assumption was wrong. And the first path was the unique path joining Vi and Vj, and this is true for all Vi and Vj in G. Okay. So now coming to the third property, which says that G is minimally connected. So what is the definition of a minimally connected graph? Minimally connected graph is a graph in which if we remove any edge, then the graph becomes disconnected. Okay. Just removing one edge makes the graph disconnected. So how do we show that the tree is a minimally connected graph? Let Vi and Vj belong to the vertex set of G such that Vi is adjacent to Vj. Just now we showed that between any two distinct vertices there is a unique path, right? And since Vi and Vj are adjacent, so this edge Vi Vj, this is the unique path between these two. That means only this edge is connecting them and there is no other path. Okay. Now, if you see, if I remove this edge, removing this makes G disconnected. See, if you are having only one edge between Vi and Vj, then if you remove it, then there is no other path, right? So what is happening? It is becoming disconnected. Why? Because there is no path now between Vi and Vj. And so what did we show? G is minimally connected. Okay. Now what is the next property? Next property says that G must have at least two leaves. And what is the definition of a leaf? A vertex of degree 1. So in a tree, there are at least two vertices of degree exactly 1. So how do I show this? See. For this proof, I am going to take the help of the handshaking lemma. What does the handshaking lemma say? That the sum of the degrees is equals to twice the cardinality of the edge set. Isn't it so? Okay. Now, suppose the order is n. That means the vertex set's cardinality is n. And since G is a tree, so of course the edge set should have cardinality n minus 1. Okay, now let k leaves be there in VG. I don't know how many leaves are there, so I am assuming that there are k number of leaves. Okay. Now, if I take the help of this property or this formula, what do I see? There are k leaves, so k vertices of degree 1, so k into 1 plus how many vertices are now there which don't have degree 1? N minus k. And these n minus k vertices must have degree at least 2. Okay. And since this is at least 2, so this thing must be lesser than or equal to the degree sum. Right? Okay. So this is what on simplification I get k plus 2n minus 2k lesser than equal to, and this thing is what? This thing is twice of the number of edges. Two n minus k, and what is this cardinality of edge set? This is n minus 1, so 2n minus k lesser than or equal to 2n minus 2. 2n gets cancelled. So what do I get? Minus k is lesser than or equal to minus 2. Okay. So if I multiply both sides by minus 1, what do I get? I get k greater than or equal to 2. And this is what we wanted to show. Isn't it so? That there are at least at least 2 number of leaves. All right.